Yeah, welcome to the new session of your engineering mathematics. So in this session, we will start with the concept of your differential equations. So let me start with the topic called as differential equations. So here also we'll have 2 to 3 marks. One mark and one 2 mark question will be there based upon the question paper set. Right. Yeah. So generally, if you speak out the many practical problems like mechanical as well as electrical engineering are formulated by finding how one quantity is related or it depends upon another quantity. Am I right or not? So many more problems it will be depends upon that only one. How one quantity is depends upon another quantity. So that relation makes you the concept of your what the representation of your what the differential equation that gives you the differential equation, that is dy by dx you will write it as. So where that y you used to call it as a dependent variable and x you used to call it as what independent variable. So that is the part of the criteria. So that relation is represented by the concept of your what the differential equations. So generally derivatives, that is that derivatives are simply interpreted as what the rate of change, that that. Am I correct or not? So here in this differential equations, you will have majorly two criteria. One is ordinary differential equation. Ordinary, used to call it as ordinary differential equation. That is ODE used to call it as. That is also simply you can call it as differential equation. Then the other one will be the partial differential equation. Partial differential equation. This is called as PDE. Then what is the difference between, you can have a doubt, sir, what is the difference between this ordinary differential equation as well as your partial differential equation? You can have a doubt. Am I right or not? So what is an ordinary differential equation is, here you will have one independent variable. One independent variable will be there. One independent variable will be there. When it comes to the part of your partial differential equation, you will have more than one independent variable. I'll explain you. More than one independent variable you will have in the concept of your partial differential equations. So that is, let me take an example here. Let me take an example. Suppose if I take the differential equation like that, you will have d square y by dx square plus dy by dx plus some y is equivalent to 0 if I have it as. See, if you observe here, if you observe this y, whatever you are having this y, all are, we used to call it as dependent variable. And then this x will be there, this x we used to call it as independent variable. This is dependent variable and independent variable. If you observe here I am having what one dependent variable and one independent variable. So that is, in the concept of your differential equation or ordinary differential equation, we will have only one independent variable. Such type of things I can call it as what? This I can call it as what? Ordinary differential equation, or simply I can call it as differential equation. Then similarly, if I take the partial differential equation, what I told, in the partial differential equation, we'll have more than one independent variable. More than one independent variable means, suppose if I take an equation like d square z by dx square plus d square z by dy square, or simply actually that partial differential equation will denote with the dou, because that is the rate of change with respect to that. So that is the reason why dou square z by dou x square plus dou square z by like dou y square plus dou square z by some dou t square, which is equal to some constant is 0, or constant c you can mention it as. That is not a big deal here. See here again, whatever I told you earlier case, this is this z, whatever you are having this z, all these z are nothing but what? Dependent variable, because this will be depends upon these x, y and t. Am I right or not? This is used to call it as independent variable. See here, x is one independent variable, y is one independent variable, and other t is nothing but what? One more independent variable. So hence here we are having more than one independent variable. I can call this as what? I can call this as what? I can call this as what? Partial differential equation. The rest of the things all are same as it is. Only the difference between this ordinary differential equation as well as a partial differential equation is, in ordinary differential equation we will have only one independent variable. In partial differential equation we will have more than one independent variable that will be there. Clear with my point? So that is the concept which you have to keep in your mind to solve a problem on the concept of your differential equation. Clear with my point? Yeah. So here first let me start with the concepts. Actually the major conditions are here is we need to concentrate much more on the order as well as the degree. The order as well as the degree concepts. Right or not? So let me take the first. I'll start with because this you already studied in your academics much more. So first let me take the order and degree of a differential equation. What is the order of a degree? What is the order of a differential equation? Yes. Generally, we'll denote this with you can take it as the highest derivative. The highest derivative involved in the differential equation. Involved in the differential equation is called the order of the differential equation. The highest derivative involved in the differential equation is called as the order of the differential equation. Let me take an example. Suppose if I have an equation like this. Suppose if I'm having a d cube y by dx cube plus 8x into dy by dx, which is equivalent to 9 cos x if I take it as. So now I want to find out the order for this differential equation. What is the order for this? Can you identify this order for this differential equation? Yes, yeah. What is the definition of your order, ma? The highest derivative involved in the differential equation is called as what? So here if you observe properly, here the highest derivative will be what, ma? Third order. Am I right or not? So hence the order for this differential equation is what? Directly I can tell it as what, ma? Order means, so which I will mention you as O, that is 3 I can mention you here. Clear with my point? So this is the order of that one. Like that you have to do it as. The same, suppose if I have one more example like this. One more example like that. Suppose if I take it as some 4 into d cube y by dx cube plus 5 into d square y by dx square plus 2 into dy by dx plus integral y into dx is equivalent to some x square by 9. Yeah. For this also you need to calculate the order. For this also you people have to calculate the order. So concentrate here. Don't go blindly. For this you need to calculate the order. Yeah, how you will calculate here? Try to understand the difference between your earlier problem and now this situation. What's the difference between that? Earlier directly you have the concept here. So there is no other variable. See here, all the things in this problem, d cube y by dx cube, d square y by dx square, dy by dx will be there. Integral y into dx will be there. So here the variable is different. Suppose if I do the integration here, what I'll get it as here? If I do the integration, what I'll get it? What I will get with respect to x, I have to do it as an integration. Am I right or not? So hence y will be the constant. So y into x you people will have it as. Am I correct or not? Yes or no? Then I have to go with this criteria. So that is the reason why if I want to make the elimination of this one, I will go with respect to what, ma? I need to do the what? Differentiation. So that differentiation integration will get cancelled. Am I right or not? So you need to differentiate the above equation. Differentiate above differential equation with respect to what? X. With respect to x. Don't get confused because this is y and this is with respect to x. Suppose instead of this y, if I have a x here, instead of y, if I have x, because both variables are what? Same. So if I do the integration, that doesn't means that is nothing but what? If I am having instead of y, it is a x. I'll have here what? X. Integration of x into dx. X square by 2 will be there. That doesn't affect your order. That does not affect any changes. Am I right or not? So that is the reason why if I take this condition, if I take if I do the differentiation for this, what will I get as here? Differentiation means what? 4 into, you will have it as what? D power 4 y by, you will have it as what? Dx power 4 plus 5 into d cube y by, 5 into d cube y by dx cube plus 2 into d square y by dx square will be there, plus integration differentiation will get cancelled, ma. You will have y, then differentiation means you will have it as what, 2x divided by 9. So now this is the differential equation. So now for this, what is the order here? Highest order will be what, ma? 4 will be there. So hence the answer for this problem is what? That is the order for this differential equation will be 4. See the same expression, ma. Suppose if I write the same expression like this. Suppose if I write 4 into d cube y by dx cube plus 5 into d square y by dx square plus 2 into dy by dx plus 2 into dy by dx plus integral x into dx. Suppose if I do it as, which is equal to some x square by 9 only if I am doing here. See what happens in this case. What I'll get it as here. Here that is not in a big deal. That is not a big deal here. If you observe that here the integral involves, see this integral is involving in the part of your what, ma? The same variable as the variable of the integration. Am I correct or not? So see, if I mention you here, this is the difference between your earlier problem. Here y y integral y into dx it is there. So that is the reason I gone for differentiation with respect to x. Am I correct or not? So but here both are the same. Both are the same. So that is, suppose if I take integral x into dx, ma, integral x into dx I will get it as what? X square by 2. That doesn't affect with respect to the order. So that is here the integral, here the integral will be what, ma? The integral involves what? A variable. That integral involves a variable same as the variable of what? Same as the variable of integration. That means that the variable as well as the integration both are same. Integration variable as well as integral variable both are what, ma? Same. Am I correct or not? So that is the part of this criteria. Getting what I'm saying here? So now in this case, directly I can tell that what? Directly I can tell my order is nothing but what, ma? Directly in this case, what is my order? What is my order here? The order is direct this thing. So no need to worry about that one. So the order is what, ma? 3 people will have it as. Clear with my point? So this won't affect with respect to your order. But earlier case is nothing but what? Earlier case differs the criteria. That also people have to keep in your mind to solve a problem. Getting what I'm saying? Are you getting what I'm saying here? Yeah. So that with the same knowledge, I will give you one more example. Can you give me the answer for that with the same criteria? If I given an example like this, d square y by dx square plus 9y which is equivalent to 2 into integral x into dx. So now for this I require the order. What is the order for this? Same explanation or not? Same explanation as your earlier case. See, here this integral will be what, ma? This integral involves a variable same as the variable of integration. That's all. No need to take it as. So same as what? Example 3. Am I correct or not? Same as example 3. That statement. So directly you can go with respect to what, ma? Directly you can go with respect to what? Yes. The order for this is what? The order is nothing but what? Yes. Directly you can represent as what? 2 you can represent it as. Am I correct or not? The order will be 2. That's all. Simple strategy. So that is how. So while going for the concept of your order, first you have to check it out. First you people have to check it out whether the integral involves a variable same as the variable of integration or not. If it is the same, then directly the highest derivative involved in the differential equation you can call it as a order. If it is not, then you have to go with what, ma? You have to go with what? Integration opposite will be what, ma? Differentiation. You have to make a differentiation. So then the integration will get cancelled. So finally you will have an answer of the order of the particular criteria. Getting what I'm saying here? Yeah, that is the part of the order of a differential equations. Clear with my point? Yeah, I hope you understood that situation. Yeah, I will discuss the degree also, and more after discussing the degree, let me go with what? The combination of the examples. Right. So now let me take the degree of a differential equation. So what do you mean by the degree of the differential equation? So what is the order? Actually, the highest derivative involved in the differential equation, I used to call it as what? The order of the differential equation. Then what about the degree of a differential equation? Here we have to concentrate the highest power of the highest derivative is called as the degree of a differential equation. Here also you have to keep in mind that you have to take the derivatives of a dependent variable should be free from the radical. Should be free from the radical in such a way that you people have to take it as that. I will take an example. You don't get bothered here. Right. So let me take the definition first. Let me take the definition. the highest power of the highest power of highest derivative. The highest power of the highest derivative is called as degree of differential equation. Degree of differential equation, provided that the derivatives of a dependent variable, should be free from the radicals. Radicals means rational values. Radicals and fractions. Clear with my point? Getting what I'm saying? So that means that is the derivative of a dependent variable contains what? So like dy by dx, like d square y by dx square whole power 1 by 2. So that is nothing but what? If I take an example, say if I'm having d square y by dx square, if I'm having here, suppose if I'm having some 3 by 2 will be there. So here it is a what? The fractional part or not? It's a radical. Radical means what? The fraction part. Am I right or not? It is a fraction part which is a by b form. So while giving the degree for this, it should be what? Free from the radical. It should be free from the radicals. So likewise you have to do it as. So that I will take an example. You don't get bother here. Clear with my point? So suppose if I'm finding if I take an example, see, while taking this, the dependent variable means what? Y is your dependent variable. That must be free from the radicals. Here you don't have any 3 by 2 values. Either 3 or 2 it may be there. Suppose if I want to make free from the radical, what I have to do it as? If I make a square of this one, so what will get is here if I'm having 2, that 2 will get cancelled. It is d square y by dx square whole power 3 will be there. Am I right or not? Based upon that, you will calculate the degree. Clear with my point? Suppose if I take an example like this. Suppose if you are having this d square y by dx square whole square, which is equivalent to x plus 4 into dy by dx whole to the power of 3 by 2 if I'm having. Yeah. Can you give me the order as well as the degree of a differential equation? Can you give me the order as well as the degree of a differential equation? If it is this one, can you give me what is the order and what is the degree for this? Can you calculate? See, how will you calculate it as? Can you give me that now? Tell me that. Yeah, usually see here, this dy by dx, actually d square y by dx square whole square, x plus 4 dy by dx will be there. It is a what? The rational value. This is a rational value. Am I right or not? So if I want to make if I want to define a degree, it should be a what? Free from the radical. Then how I will do it as? Making a square on both sides. So square on both sides, if I want to eliminate that free from the radicals, so I need to do it as what? Square on both sides. So if I do the square on both sides, what I'll get as here? If I do the square on both sides, d square y by, I'll have here what? Dx square. Square means 2 into 2, which is a 4. That is equal to what? X plus 4 into dy by dx. If I make a square on both sides, I'll get as what? That 3 and 2. 3 by 2 into 2 will be there. 2 will get cancelled. I'll have it as what? 3 will be there. Am I right or not? So now it is free from the radicals or not? Now it is free from the radical or not? Yeah. So what is order now? Order is nothing but what? The highest derivative involved in the differential equation. What is the highest derivative? Highest derivative will be 2. Am I right or not? Then similarly, degree will be what? The highest power of the highest derivative. See, don't take it as this is nothing but what? Dy by dx. This is whole power 3. But it is not required. The highest power of the highest derivative. So highest derivative is 2 will be there. The power will be 4. So hence the degree for this is nothing but what? Hence the degree for this is what? 4 you have to calculate it as. That is how you need to calculate the order as well as the degree. That should be free from the radicals. Clear with my point? So in such a way that you people have to calculate the order as well as the degree for the corresponding equations. So this will be applicable for both ordinary differential equation as well as your partial differential equation. This will be applicable for both ordinary differential equation as well as your partial differential equations. Clear with my point? Yeah. So now let me take some more examples which was asked in the previous years. Okay. So let me take those questions. I hope you understood the concept here. Clear? Maybe. Am I correct or not? Yeah. So let me take some more examples based upon that. So find the order and degree for the following differential equations. Let me take the question. Find the order and degree for the following differential equations. That is a uniform question. Find the order and degree. Find the order and degree for the following differential equations. So I hope you understood, right? So let me take the questions here. I already solved them. So now let me take the questions. Am I right or not? So just to find the order as well as the degree for that. So hope you will do it. As if you are not getting, you can ask me that doubts. Okay. Yeah. So let me take the questions like this. I'll have here y dash is equivalent to 2x square. This is the first question. Next, like y double dash, you know that y dash means dy by dx. That you know that. Am I right or not? Yeah. So next y double dash plus 3y dash plus 2y is equivalent to 4x. So come on, let me calculate. Take down these criterias. Next, x square into y double dash minus xy dash plus 9y is equivalent to log x. Yeah. So can you tell me what is the order for this differential equation, ma? It's a simple differential equation only. I hope you know that order is 1 and similarly degree is also what, ma? 1. Order I am representing O, degree I am representing with the D, ma. Right? Yeah. So here also, what is order? See, highest derivative will be what, ma? This. The power will be 1. So that is the reason why I written. Here also, highest derivative will be 2. That is order 2. And degree will be what, ma? The derivative, the power will be 1. Yeah. So likewise. Similarly here, same thing. Order 2, you will have a degree will be what? 1. So likewise, you people have to solve the criteria. Clear up my point? Yeah. Next, some more examples. Next one, y dash into y double dash plus y cube is equivalent to x cube. Next, 1 plus y dash whole cube whole power 1 by 2, which is equivalent to 10 into y. Next, sixth one, y dash is equivalent to root x plus root y. Yeah, tell me the answers for this. Directly for this, order is what, ma? See here, dy by dx into d square y by dx square. Right? So order will be 2 and degree will be what, ma? Degree will be what? The power. For this power will be 1. So hence 1 will be there. This also, again I need to make it as what? Free from the radicals. 1 plus dy by dx whole cube whole power 1 by 2 will be there. So if I want to make the free from the radicals, I need to make the square on both sides. 10 into y square will be there. Here the 2 will be getting cancelled. In this case, the order will be what, ma? Order will be 1. Power will be what? Degree, that is 3 will be there. Am I right or not? Yeah, this also order will be 1. Degree will be 1, you will have it as. Am I correct or not? Yeah. So likewise, you need to solve the criteria. So then next one, y triple dash whole square is equivalent to 1 plus y dash whole cube. Next, y triple dash plus 8y double dash plus 2y dash plus y is equivalent to 0. Yes? Yeah, give me that. Yes. Next, 1 plus dy by dx whole square whole power 3 is equal to c square d square y by dx square whole square ma. Yeah, calculate the order and degree for this. Come on. What is the order for this ma? This is 3. Correct or not? Yeah, degree will be what? Square. So hence 2 will be there. Similarly for this, order 3, degree will be 1. Right? Yeah, for this also, order. This is nothing but what ma? Highest derivative. Not this. This one. Highest derivative will be 2 and the highest power of the highest derivative. That is a degree. Degree is also what? Degree will be what ma? Yeah, degree will be 2. Clear na? Yeah, that is how you have to do test. Then similarly, next problem. Next one, yeah, d by dx into d by dx into x square d square y by dx square whole cube plus cos of xy is equivalent to e to the power of x ma. Yeah, give me the answer for this. They given here what ma? D by dx means you have to form the differentiation. Am I right or not? Yeah. So how we will do it as differentiation? This is u into v rule, right? So if I do the differentiation here, I'll get as what? 3 this one. 3 into d square y by dx square whole square. X power n into x to the power of n minus 1. Then again for this d square y by dx square, you will have it as what? D cube y by dx cube will be there. Am I correct? Yeah. Right? Into u into dv by dx plus v into dv by dx. So into x square will be there. Yeah, x square plus again for x square you will have it as what ma? Dx will be the differentiation. Sorry, 2x will be the differentiation. Then again you will have it as what? D square y by dx square whole cube will be there. Am I right or not? Yeah, plus cos of xy, which is equivalent to what? E power x. Because this differentiation is only for up to this term, not for these two things. Am I right or not? Yeah. So now can you tell me what is the order as well as the degree for this? What is order here? Highest derivative will be what ma? This d cube. So this is 3 and this power will be 1. So hence degree will be 1. So you have to concentrate much more ma. They given here what? D by dx of this part they had given. Clear ma? Likewise you have to get the criteria. Clear? Understood what I am saying here? Yeah. Then similarly, one more. I think this is number 11. Yeah. This is number 11. We will go it as. Yeah. Take that. Y is equivalent to x into d square y by dx square plus 15 into root of 1 plus d square y by dx square whole square. Yeah, give me that. Here if you observe here, you will have what? Yeah, how you will solve it as? Again here we are having what ma? Square root will be there. So now how we will do it as? This you take it as a left hand side. So y minus x into d square y by dx square, which is equivalent to 15 into square root of 1 plus d square y by dx square whole square. So if I want to eliminate this square root ma, because this I can represent as what? 1 whole power 1 by 2. So hence if I square on both sides, so make a square on both sides. Square if I do it as this square root will get cancelled. So square on both sides. What I will get as here? Yeah, y minus x into d square y by dx square whole square, which is equivalent to 15. This square root will get cancelled ma. That is square root of, you will have 1 plus d square y by dx square whole square. This will be what? Whole square you will have it as. So if I do it, that square root will get cancelled. This is a minus b whole square ma. A square minus b square. Sorry, a square plus b square minus 2ab will do it as. So if I do that, what I will get as here? Y square minus 2ab. So 2 into xy d square y by dx square plus b square. So plus x square d square y by dx square whole square, which is equivalent to what ma? For this, if I make a square on both sides, that square root 15 square, you will have 225. Then into that square root will get cancelled. You will have it as what? 1 plus d square y by dx square whole square will be there. Am I correct or no? That square root will get cancelled. Yes or no? Yeah. Now in this case, can you tell me what is the order and what is the degree for this highest derivative in the both the cases? So 2, highest power of the highest derivative. Am I correct or not? So likewise, you people have to do it as the concepts. Clear with my point? Yes or no? Yes or no, ma? So this is how you people have to go with the concepts of your order as well as the degree for the corresponding differential equations. So I hope you understood the concept of these criteria. Getting what I'm saying here? Yeah, let me take 2 to 3 examples on the partial differential equations also, so that you will have an idea. So let me take the next one. You will have a dou cube w by dou x cube is equivalent to u into dou u by dou y. Next, dou square u by dou x square is equivalent to 1 by c square into dou u by dou t. Next, dou square u by dou x square plus dou square u by dou y square plus dou square u by dou z square is equivalent to 0. Yeah, can you give me the order and degree for this following differential equations? Yeah, come on. Give me that. Yes, ma. How you will solve it as? So highest derivative will be what, ma? Order will be 3, degree will be 1. Then for this, order will be 2, degree will be 1. For this also, order will be 2, degree will be what? 1. Am I correct or not? So likewise, you people have to do the concepts with respect to your what, ma? The order as well as the degree for the corresponding differential equations. Clear with my point? Getting what I'm saying here? Yeah. So likewise, you people have to go with the things. Understood what I'm saying here? So I hope you will solve the problems based upon your order as well as the degree for the differential equations. So this is the first most concept. So many more questions they asked from the concept of this order as well as your degree of your corresponding differential equations. Right? Yeah. Next, let me take the next topic, which is called as the formation of a differential equation. Let me take how you have to form the differential equation. So that is the formation of differential equation. Now you need to form the differential equation. How you have to form the differential equation? So let me take the steps here. See, let capital F, which is having x comma y are the variables, a comma b are the constant, which is equivalent to 0. This you take it as equation 1. Yeah. Now the concept here is the differential equation. If you observe all the differential equation what I had given earlier, total 14 earlier questions, somewhat questions I just given you the examples. If you observe all those, it must be a variable of x and y. Am I right or not? So there is no constant in that. So the constant also which is multiplied by the variables x and y. So in such a way that you have to form the differential equation. Am I right or not? So that is, see here x and y are the variables, but a and b are the what, ma? Constants. So you have to form a differential equation like that. There is no constants in the given differential equation. That means you need to eliminate the constant here. Then how you will eliminate that constants, that is a and b, how you people have to eliminate it as. So here you have to go with the differentiation. See here I am having two different constants like a and b will be there. The best concept here is in the differential equation, first you have to identify the number of constants. That many number of times you have to differentiate it as. That is the order for the corresponding differential equation. See here I am having two constants here. So by directly you can tell the differential equation will be the second order differential equation. That is the number of arbitrary constants. That is a and b I can call it as the arbitrary constants. The number of arbitrary constants should be eliminated. That is equivalent to the what? The order of the resulting ordinary differential equation. That number of arbitrary constant is equivalent to the order of the differential equation. And that to that many number of times you have to differentiate the given differential equation. That point you should keep in your mind to solve the particular criteria. Getting what I'm saying here? Yeah. So now this I need to take it as you need to differentiate equation 1 with respect to x. So what I'll get as here, if I do the differentiation with respect to x, I'll take it as first order differentiation, which is f1. So that is x comma y will be there. With respect to x, I'm differentiating that y will be what, dy by dx will be there or not? Yeah, dy by dx comma a comma b will be there. That is equivalent to 0. This you take it as a 2 equation. Am I right or not? Now, with respect to one constant, I got dy by dx. Again, if I want to make one more thing, this is with respect to one constant. Again, I want to go with respect to what, Yeah, if I want to eliminate that, you'll go to what? One more differentiation with respect to x. So this differentiation I'm taking it as what? f2. Second time differentiation. So x comma y, then dy by dx will be there. Again, for dy by dx, what is the differentiation? You will have it as d square y by dx square comma a comma b, which is equivalent to 0. This is equation 3. So now if you observe here with respect to two constants, you are having what, the higher order, that is the second order differential equation will be there. So now I need to eliminate this arbitrary constant. This is your arbitrary constant. So that is eliminate. I will tell you how you have to eliminate this one. I will take an example. You will have an idea. Eliminate the arbitrary constants. Eliminate the arbitrary constants. That is a comma b. You have to eliminate it as. After eliminating that, you will have an equation like some pi, which is a variable, x comma y, which is dy by dx comma d square y by dx square will be there, which is equivalent to 0. So this is the differential equation which you have formed without any constants. Am I right or not? So this is the part which you have to keep in your mind to solve this point. Here you have to make a note point that what I told, here I have two constants. Suppose in your differential equation, if you are having only one constant, only one time you people have to differentiate it as. That's all. That is nothing more important here. So that is the order of the differential equation is the equivalent to what, the number of variables. So that means that take that note point here. What is that note is the number of arbitrary constant, the number of arbitrary constants eliminated. The number of arbitrary constants eliminated should be equal to the order of the resulting ordinary differential equation. Order of the resulting ordinary differential equation. Clear with my point? So that means if you are having the number of constants, the number of arbitrary constants, which is equal to the resulting ordinary differential equation. That point you have to keep in your mind. Getting what I'm saying here? Yeah, for understanding this, let me take an example. In order to understand that, let me take an example. Find the differential equation. Find the differential equation. DE means differential equation. Find the differential equation of family of curves. Find the differential equation of a family of curves. Y is equivalent to c into x minus c whole square. Find the differential equations of the family of the curves. Y is equivalent to c into x minus c whole square. This is the question they asked you. Yeah. First, after giving the question in the part of this, first you have to observe how many number of constants are there. According to that number of constants, you have to differentiate it as. Am I correct or not? Yeah. So here, if you observe properly, the given different equation is nothing but what they had given. Given y is equivalent to c into x minus c whole square. That is what they had given or not? Yes or no? Yeah. So according to that, you are having here only one constant. So one time if you are differentiating, that is more than enough. Then you have to eliminate what? The constant c, you have to eliminate it as. So take this as equation 1. So differentiate this equation 1. Differentiate equation 1 with respect to what? With respect to x. Am I right or not? Yeah, if you do the differentiation with respect to x, what I will get as here? Y dash is equivalent to c into, that is what? 2 into x minus c. For again x, you will have it as what? 1. So which is nothing but what? 2c into x minus c, which is. So this you take it as equation 2. So one time I just done what? The differentiation. Now I need to get it as what? I need to eliminate my constant c. Am I right or not? So for that, let me take, if I take equation 1 with the equation 2 division. If I take equation 1 divided by equation 2, what I will get as here? Equation 1 is what ma? Y, which is equivalent to what? C into x minus c whole square divided by 2 means what? Y dash divided by what? This one. 2c into x minus c will be there. So now if you observe here properly, this c will get cancelled, x minus c whole square and x minus c will be there. So now if I eliminate this, if I do that, what I will get as here? If I do this one, I will get as what ma? This x minus c, which is equivalent to what? This 2 will be there. 2y divided by what ma? Y dash will be there. Am I right or not? So x minus c is equivalent to 2y by y dash will be there. Now from this, what is the value of your c? What is the value of your c here? From this, if you take it as, you will have it as what? X minus 2y by y dash. Again, take cross multiplication of this. Again, take the cross multiplication of this one. C is equal to what? X y dash minus 2y by y dash will be there. This is what? Your x minus c, the value of your c. Am I correct or not? Yeah. Now, if you observe, this is the value of your x minus c. So, these two values, if you substitute in the equation 1, if you substitute these two things in the equation 1, see, if I want to eliminate this one, this is c value, this is x minus c value. If I substitute these, that c and x minus c value, then obviously that c value will be eliminated or not? Obviously that c value will be eliminated or not? Yeah, so substitute that, so right here, substitute here, substitute c and x minus c in equation 1. Yeah, so substitute this is c and x minus c in equation 1 ma. So what you will get it as here? Check it out. So equation 1 is y is equivalent to c into x minus c whole square. Am I correct or wrong? Yeah. So that is the part of this one. So y is equal to c into x minus c whole square. So if I substitute these values, so what I will get as, check it out, y is equivalent to c will be what ma? Check it out, c will be xy dash minus 2y divided by y dash. This is my c value. Yeah, x minus c whole square. X minus c will be 2y by y dash. If I do that square on both sides, then I will have here what? 4y square by y dash square. Don't get confused. Y dash means dy by dx whole square, right? So now if you check it properly, make a cancellation. This y will get cancelled, y will get cancelled. Yeah. So if you realign this, you will have it as y dash cube is equivalent to, see, y dash square, y dash. So y dash into y dash square will be y dash cube. So which is equivalent to xy dash minus 2y into 4y. So this is the final equation. You can do it as, you can cross verify it as y dash means what? Dy by dx whole cube minus x into dy by dx. The short form I just written it as. If you want, you can multiply both of this. If you want, you can go with all the criteria. Clear up my point? Yeah. So this is how you have to go with the formation of the differential equations. Clear now? Yeah. So based upon this analysis, let me go with some more examples. So find the differential equation for next example. Next example. Find the differential equation. Find the differential equation for y is equivalent to a into cos 2x plus b into sin 2x. Find the differential equation for y is equivalent to a cos 2x plus b sin 2x. So if you observe here properly, so you will have the concept of what? Two constants are there. A is one constant and b is another constant. So if I want to get this one, I have to eliminate what ma? I have to eliminate what? These two constants. Am I correct or wrong? Yeah, here we are having two constants, a and b. So two times you have to differentiate this equation. So let me take the given equation will be what ma? So that is y is equivalent to a cos 2x plus b into sin 2x. So first time if I do the differentiation, directly I am doing ma. So y dash is equivalent to what? For cos you will have it as what? Minus sin 2x. Again 2 you will have it as directly I am representing this. So minus 2a sin 2x plus 2b cos 2x will be there. Am I right? Yeah. So this is what. Then again one more differentiation, which is nothing but what, y double dash, which is equivalent to, already 2 is there, which is what, minus 4a into cos 2x minus 4b into sin 2x will be there. Right. So if you observe properly, this, if I take it as equation 1, if you observe here, if I take minus 4 as a common, if I take minus 4 as a common, what will I get as here? Minus 4, if I take it as a common, I'll have a cos 2x plus b sin 2x. So if you observe properly, this is your y double dash. If you observe properly, this a cos 2x plus b sin 2x will be what? Your y. So this, if I replace it as, I'll get it as what? The value of your y. So in such a way that I can able to eliminate that one. So y double dash is equivalent to minus 4y. Then your differential equation will be what? Y double dash plus 4y is equivalent to 0 is the differential equation for the corresponding thing. Am I right or not? Yeah, that is how you people have to solve it as. Clear? Yeah. In the same manner, can you try one more example? Yes. So these are the things which you have to keep in your mind. Yeah. So x is equivalent to a cos nt plus alpha, where a and alpha are constants. A and alpha are constants they had given. Yeah, give me the solution. That means that what? A and alpha are the constants means n and t are the variables. So here if you observe x variable, so you will have it as what? With respect to t. See, the variable will be what? T. With respect to t, you people have to do the differentiation. So that is, you will go with what? A and alpha constant. So you will have it as what? Dx divided by dt, you people have to do it as. So for that, what you will get it as here? Minus, because for cos differentiation, minus you will have it as. Again for n, you will have it as nt, you will have it as what? N. So directly I am representing this as n into a sine of nt plus alpha. This is the first time differentiation. Am I right or not? Yes, with respect to this. Then one more differentiation, which is nothing but what? D square x by dt square. One more differentiation will be what? Already minus will be there. N into n will have it as what? N square into a. Again for this, we will have it as what? Cos of nt plus alpha will be there. Am I correct or not? Yeah, if you observe properly this, again, a cos nt plus alpha, which is nothing but what? X only, na? Yeah. So directly you can do that one. So in the equation, so you will have it as what? Which is d square x by dt square, which is equal to what? Minus n square into x will be there. So directly if I write it as d square x by dt square plus n square x is equivalent to 0. This is what? The differential equation. Am I correct or wrong? This is your differential equation. So likewise, you people have to do it as. Yeah, can you try one more based upon this? Yeah, y is equivalent to bx plus 1 by b. Y is equivalent to bx plus 1 by b, where b is not equivalent to 0. Yeah, try to solve it more. Again, here b is what? Your constant. Am I right or not? Yeah. So one time if you are making the differentiation, it's more than enough. So that is you will have it as what? So that if I take y dash, so I'll have here what? Y dash is equivalent to what? With respect to x, this only will be there. So y dash is equivalent to b will be there. So directly b, if I replace it as what? Y, I'll have it as what? The same thing. So y is equivalent to b means what? Y dash into x plus 1 by y dash. So take the LCM and solve it. You will have it as what? X into y dash whole square. Simplify it as minus y dash plus 1 is equivalent to 0. This is the differential equation for the corresponding equation. Am I correct or wrong? Yes or no? Yeah, that is how you people have to solve it as. Clear now? Is there any problem with that? Yes? Clear? Yeah. Then one more you can do it as, which is nothing but what now? You can take here. Yeah, one more thing. Maybe you will do it as these things. Nothing here. So xy is equivalent to a e to the power of x plus b e to the power of minus x plus x square, where a and b are the constants. A and b are constants. Yeah, try to solve this again. Solve it. I'm just giving a homework for this, you guys here. I'm just giving this as a homework. You can get it as. So I'm writing that answer for this. So two constants are there. So 2 times you have to do the what differentiation and substitute this one. So you'll have an answer of, I'm just writing directly answer. So 2y dash, you will have a 2y dash plus xy double dash, 2y dash plus xy double dash minus xy plus x square minus 2 is equivalent to 0. This is the differential equation. Try to check it out. I'm just giving a homework to you guys. Okay. Yeah, next one more problem. One more problem as an homework. Yeah. Y square is equivalent to 4a into x plus a. A is constant. Yeah, one time if you are doing differentiation, it's more than enough. So I'm just giving directly answer for this also. You will have a y square, y dash square plus 2xy y dash minus y square is equal to 0. Check it out. If you are not getting, you just WhatsApp me, I will give the solution for this. Okay. So kindly check it out. Kindly check it out, ma. Okay. Yeah. Kindly check it out. Yeah, then can you take one more previous question based upon this analysis? Take that. Which one of the following differential equations? Which one of the following differential equations? Note down the question. Which one of the following differential equations? Which one of the following differential equations has a solution? Has a solution given by the function y is equivalent to 5 sine 3x plus pi by 3. The options are dy by dx plus 5 by 3 cos of 3x is equivalent to 0. Option B, dy by dx minus 5 by 3 cos of 3x is equivalent to 0. And C, d square y by dx square plus 9y is equivalent to 0. And D, d square y by dx square minus 9y is equivalent to 0. These are the criteria. Yeah. Check it out, ma. How you people have to solve this question? Which one of the following differential equation has a solution given by the function of this one? Solution means what, ma? Just a differential equation. Y is equivalent to, they given what? Y is equal to 5 sine 3x plus pi by 3 they had given. Am I right or not? So if you observe here properly, with the terms of, you will have it as what? dy by dx will be there. You can cross verify it as which one it will process it as. Am I right or not? So check it out how I can able to solve this one. That is what the criteria. So let me take the given equation now. What is the given equation here? Let me take y is equivalent to 5 sine 3x plus pi by 3 they had given it as. Am I correct or wrong? Yeah. Now let me go with the differentiation with respect to x. So that is dy by dx. If I do it as dy by dx is equal to what, ma? You know that this 3 will comes here. I can represent directly this as 15 cos of 3x plus pi by 3 I can do it as. So it is not showing any option. Am I right or not? Then try for second time derivative. Try for that. So do that second derivative d square y by dx square, which is equal to what, ma? Again you will have it as what? Minus 15 into this 3 will be there. Then again we will have it as what? Sine of 3x plus pi by 3 will be there. So this I can represent as what, ma? Minus 15 means what? Minus 15 means what? Minus 15 into 3 means minus 45 will be there. This I can represent it as, if you check it out properly, this as minus 9 into 5 sine 3x plus pi by 3 if I take it as. So now this you take it as equation 1 ma. Yeah, this what is this? 5 sine 3x plus pi by 3 will be what? Y or not? Yes or no? This is your y. Yeah, then directly you will go with what? You will have it as what? This will be what ma? D square y by dx square is equivalent to minus 9y will be there. So now you will have the differential equation d square y by dx square plus 9y which is equivalent to 0. This is the differential equation for the corresponding thing. So hence which option is correct? Option C is the right answer. Am I correct or not? Yes or no? That is how you people have to do the analysis like that. Clear with my point? Understanding what I'm saying? You're understanding what I'm saying, Mama? Yeah, like that you people have to go through it as. Clear with my point? Yes, I hope you people are understanding the concepts. Am I correct or wrong? Am I correct or wrong, ma? Yeah, next one more easiest thing. Maybe in your academics also maybe you people studied this one. So let me take that question. It's a peculiar question actually. Yeah, take that question, ma. Find the differential equation. Find the differential equation of a family of find the differential equation of a family of circles with the center h comma k, with the center h comma k and radius a, and radius a, where h comma k are the arbitrary constants. Where h comma k are the arbitrary constants. Where h comma k are the arbitrary constants. Am I correct or wrong? Yeah. So this is the question that I had given. You know that the family of the circles, family of the circles with the center h comma k and radius a. You know that. What is that? Circle equation is nothing but what, ma? Circle equation with the center. Circle equation with the center h comma k and radius a will be what, ma? You know that will be what? X minus h whole square plus y minus k whole square is equal to what? X minus h whole square plus y minus k whole square is equal to what? A square. This is the circle equation with the center h comma k and radius a. Am I correct or wrong? Yeah. So here what they told? They told h and k are the arbitrary constants. With respect to h and k, you people have to go with what, ma? The constants. So let me try that. So go with the two times of differentiation. So you need to eliminate your h and k. Am I right or not? So do that differentiation with respect to x. What you will get as here? Differentiation with respect to what, ma? X if I do it as. So what I will get as here? 2 into x minus h plus 2 into y minus k into y dash. With respect to x if I am doing. So that is I'll have it as dy by dx is equivalent to 0. So a square is a constant, so that directly I am representing. So from this you can go with what, ma? That 2 will get cancelled, ma. If I take both this, so I'll have here what? X minus h I'm taking. X minus h is equivalent to minus y dash into y minus k. I can take it as. This is what my x minus k. Am I correct or wrong? Yes. Yeah, that directly I'm taking. I can replace it as. Then again you need to go with what, ma? Differentiation with respect to what? With respect to x again. So take this as equation 2. If I do the differentiation with respect to x again, this one. What I will get as again here for x 1 will be there, which is equal to what, ma? Minus uv rule. So y dash into y minus k, uv rule. So for y dash, y double dash will be there into y minus k. Then minus for y dash, same y will be there. For my y minus k, k is constant 0, for y dash will be there. Am I correct or not? Yeah. So from this you can, if I simplify it as, you can take y minus k, ma. So for getting that y minus k, what I have to do it as y double dash into y minus k is equivalent to what? Minus y dash square, y dash into y dash square. This minus 1 will be there. From that, what is my y minus k? From that, what is my y minus k, ma? Yeah, y minus k is equivalent to, you will have it as what? Minus, I am just taking this as a common, so you will have it as what? Minus, if I take it as common, minus 1 plus y dash square divided by what? This y dash will be there. So that is y double dash will be there. So this is one more equation, y minus k. So now I can replace that x minus h and y minus k then I can remove easily what? X minus k as well as y minus k. So substitute 3 in 2 because x minus k, x minus h. See, if you are observing here, x minus h, there will be y minus k will be there. This also I need to eliminate it as. So for that, I'll just substitute this in this equation. So that means substitute equation 3 in 4. Sorry, this I'm just taking it as what Sorry, substitute that 3 in equation 2 So just write that substitute equation 3 in equation 2. What I'll get as here? Substitute equation 3 in equation 2. If I substitute, I'll have here what x minus h is equal to y dash into 1 plus that minus will get plus y dash square divided by what? Y double dash will be there. Am I right or not? Yes or no? So now this will be what? Your x minus h. So now all that is x minus h and y minus k will be what in terms of y dashes. So this is equation 4 if you take it as. So now if in order to eliminate this x minus h value and y minus k value. So you know that now you calculated x minus h, y minus k. These two values if you are substituting there, it will be eliminated by what that h and k value will be eliminated. So now simply substitute. Now substitute equation 3 and 4 in 1 in equation 1. So what will get as here? Try to check it out. I am directly representing so y dash square into y 1 plus y dash square whole square by y double dash square plus 1 plus y dash square whole square by y double dash square is equal to a square. That you will get it as. Try to check it out. Because it's a square, so that is the reason why I'm directly representing that in the form of your square Okay, yeah. So now what will get as if I simplify it, nothing will happen here. Simplify it as, if I simplify that, I will have it as what? 1 plus y dash square whole square plus into 1 plus y dash square, which is equal to what? Y double dash square into a square. So again this y dash square into y dash means you will have it as what What again? You will have it as what? Cube will be there. So that is 1 plus y dash square, 1 plus y dash square whole cube is equivalent to y double dash square into a square will be there. Am I correct or not? So this is the part of your what? This is the particular differential equation. Clear with my point? Are you getting what I'm saying here? Yeah. So I eliminated my h and k. So here this is, if you verify it the differential equation, whatever the differential equation you got it as here, that is a second order differential equation or not? Yeah. See, two constants I eliminated, that is h and k was eliminated. So hence my differential equation will be what My differential equation order will be what? 2 will be there. So that in such a way that you people have to cross verify it as. Clear with my point? Clear with my point? Yeah, that is how you people have to do it as. Clear na? Yeah. Yeah. So that is how you people have to solve it as. So let me try one more problem based upon that. So take that. The differential equation of a family of straight line passing through origin is option A, y dy plus x dx is equal to 0. Option B, y dy minus x dx is equal to 0. Option C, x dy minus y dx is equal to 0. And D, none of the above. None of the above. This is the question. So what I had given the question? The differential equation of the family of a straight line passing through the origin. Family of a straight line passing through the origin they are asking. So what is the straight line passes through the origin? But you know that the straight line, generally the straight line is, equation is what y is equal to mx plus c actually. But if it is passes through origin means what ma? This C is equivalent to 0. So hence y is equivalent to mx will be the straight line passes through origin. Am I right or not? So now here I have only one what I can say that the constant. So one time if I do the differentiation, what I will get as here dy by dx is equivalent to what ma? M will be there. So now that is y dash is equivalent to what? M will be there. Now that is y dash only. So now if I substitute m as y dash there, what I will get as here? If I substitute here, what will get as here? Y is equal to what ma? Dy by dx into x. So do the cross multiplication here. What do you will have it as? Y dx minus x dy is equivalent to 0. Or you can go directly with respect to what ma? X dy minus what? Y dx is equivalent to 0. This is the straight line equation passes through the origin. So hence which option is correct? Option C is the right answer. You can cross verify it as. Clear with my point? Understanding what I'm saying here? Getting what I'm saying here? Yeah. This is how you people have to form the differential equation. See ma'am, sometimes directly they will ask you. This is how the direct approach for the given problems. Suppose sometimes if I make a note point of this is also very important here. So make a note point of this. Make a note. Yeah. This is a first note point. If the given equation is of the form, y is equivalent to c1 e to the power of x plus c2 e to the power of bx plus and so on, like that. If the given equation is of the form y is equal to c1 e to the power of x plus c2 e to the power of bx plus and so on, then the differential equation is, you can represent it as d minus a, where a is what ma? This value, a, b, like that. D minus a into d minus b into d minus c into y is equivalent to 0. So this is the differential equation for such type of forms. Clear with my point? So this is the particular equation is of the form which you can able to do it as. Where you can ask a doubt, sir, what is it that d? Where d is nothing but what ma? D by dx. If it is a x variable. Similarly, d square means what? D square by dx square. It depends upon the variables ma. Here I am just assuming that as what? X as a variable, right? So similarly, d cube means what? D cube divided by dx cube and so on. Like that you people have to do it as. Clear with my point? Yeah. So in order to understand this, let me take an example. So find the differential equation, or you can take it as if y is equivalent to c1 e to the power of minus x plus c3 e to the power of 3x plus k into e to the power of 4x, then the differential equation is, this is the question they are asking. So how will you solve it as? This is the question mark. If y is equivalent to c1 e to the power of minus x plus c3 e to the power of 3x plus k e to the power of 4x, then the differential equation is they are asking. So if you compare this with respect to c1 e to the power of ax plus c2 e to the power of bx and so on, so the value of your a is what ma here? Minus 1, then b will be what? 3, and c will be what ma? 4. So now the differential equation will be what? Here we are having 3 constants. So that is with respect to the given differential equation. The differential equation for this is d minus a into d minus b into d minus c into y is equal to 0 will be there. So then what is that a value here? Minus 1. Minus half minus, what do people have it as? Plus. So d plus 1 into d minus 3 into d minus 4 into y is equal to 0. So this is what the thing. So if you simplify it as, you will have it as what? If you simplify it as what? This one, d square plus d minus 3d, you will have it as what? D square minus 2d minus 3 will be there into again d minus 4 into y is equal to 0. Again if you simplify it as, you will have it as what? D cube. If you simplify it as d cube minus 6d square plus 5d plus what ma? 12 into y is equal to 0. Now if I write in the form of the expanded form, d cube means what ma? This d cube means d cube by dx cube. Am I right or not? This y will be multiplied. So d cube y by dx cube minus 6 into d square y by dx square plus 5 into dy by dx plus 12y is equivalent to 0. This is the differential equation for the corresponding thing. Are you understanding what I'm saying here? If the given equation is of the form like that, directly you can represent here what ma? Directly you can represent these criteria. Clear with my point? This is how you people have to solve it as. Clear ma? Yeah. Can you try one more example with the same thing? Can you try one more example here? Yeah. Take down that. If I is equivalent to c1 e to the power of minus 2t, c1 e to the power of minus 2t plus c2 e to the power of 3t, then the differential equation is, this is the question. Then the differential equation is, earlier will be what ma? In terms of y and x, but here in terms of your what ma? I and t. So now directly the d will be what? Usually earlier this d will be what? D is nothing but what ma? Dy by dx I have represented there. Am I correct or not? So now it will be what? Di. So the di will be what? Di by dt. You people have to do it test. That you have to concentrate as. So a will be what ma? Minus 2 and b will be what? 3 will be there. So for this the differential equation will be what? Differential equation will be what ma? D minus minus of minus plus will be there. So d plus 2 into d minus 3 into here what? Earlier it is with respect to y ma, but here with respect to what? I. So into I is equivalent to 0. So now if I multiply this one, I'll have it as what? D square minus d minus 6 into I, which is equivalent to 0. So now if I simplify it as what? Now with respect to t will be there. So that is d square I by dt square minus di by dt minus 6i is equivalent to 0. So this is the differential equation for the corresponding equation. Am I right or not? So that is how you people have to take it as one. And one more analysis, the same one note point. One more note point, that is a note 2. You take it as this is the one will be the note 1 point. So take the note 2 point. Let me take the note 2. Yeah. Here what I'm taking, same. If the given equation is of the form, y is equivalent to a into f of x plus a b into g of x, then the differential equation is obtained by simplifying the determinant. This itself we can call it as Wronskian determinant. This determinant itself we used to call it as Wronskian determinant. Just name itself, that's all, nothing more than that. Wronskian determinant. Okay, so that is, they just given you y here, f of x, this is g of x, right? Yeah. Then simply for this y dash, for this f dash, for this g dash, similarly y double dash, see here this is f dash x only, this is also x, then again f double dash of x, then it will be g double dash of x. So this is a third order determinant, right? So which is equivalent to 0. So this itself I am calling it as Wronskian determinant. So by simplifying this determinant, we can go with respect to what ma? This equation. If the given equation is of the form y is equivalent to a into f of x plus b into g of x if you are having. So like that you have to do it as. So let me take an example for understanding this. If y is equivalent to a e to the power of 2x plus bx, then the differential equation is, this is the question. Yeah, how you people will solve it as, generally a into f of x, this is my f of x, then b into g of x, this is your g of x. So now substitute this one. So I'll have here what actually y, f of x and g of x. Am I correct or not? This is what the criteria. So now can you tell me what is the y? Y is same, similar thing. Y, f of x is what ma? E to the power of 2x. Then g of x is what? X. Then what I need to do test for this? I have to go with what ma? The differentiation. So this is y dash. What's the differentiation for this? 2e power 2x. Differentiation of this 1 will be there. Then again y double dash differentiation 4e to the power of 2x. Differentiation will be 0. So now this determinant, this is called as what ma? Wronskian determinant. That I have to make it as 0. So simplify the determinant here. Simplify the determinant here. What do people get as here? Y into what? Y into AD minus BC. If I take this one, so I'll have here what? So let me take the things. So if I take this one y with respect to this, simplify the equation and give me the answer for that. So give me that answer for that. Come on. Third determinant y into, you'll have it as what? AD minus BC. So AD is 0. You'll have it as what? Yeah, what will get as here with respect to y if I'm doing AD minus BC. So I need to eliminate this column. I need to eliminate this row. So this is this 2e power 2x 1, 4e power 2x 0. So AD minus BC. So this is 0 minus you'll have it as what? Y into minus 4e to the power of 2x minus 0 will be there. AD, sorry, 0 minus yeah, AD minus BC 0 minus of this one. Yeah, next minus e to the power of 2x into what for this? 0 into y dash. This is 0 minus y double dash. Am I right or not? Yeah, next one plus x into again x into y dash 4 e to the power of 2x minus y double dash e to the power of you will have a 2 also, it will be there now. 2 into e to the power of 2x, which is equivalent to 0. Am I correct or not? Yeah. So if you multiply, you will have it as what? Minus. So that is minus 4 y e to the power of 2x minus of minus plus will be there. E power 2x y double dash plus x y dash or you can take that 4x y dash e to the power of 2x minus 2x y double dash e to the power of 2x is equivalent to 0. Am I correct or not? Yeah. So now if you simplify it as, check it out ma, you can simplify this. So take e to the power of 2x as a common there. Okay. So keep outside that, you will have it as what here? You will have it as what ma? E to the power of 2x, if I take it as a common in all those, you will have it as what? Minus 4y plus y double dash plus 4xy dash minus 2xy double dash is equivalent to 0. You will have it as, if I take p power 2x as a common outside, then you people have this one. So now let me take this one. Take y double dash as a common here. Yeah, y double dash because in this you will have this one. So y double dash if I take it as a common, I will have it as what ma? 1 minus 2x will be there plus 4x y dash will be there minus 4y is equivalent to 0. So this is the differential equation you will have it as. Am I correct? Yeah, try to check it, this one. Just simplifying, that's all ma. So go with the Wronskian determinant, that's all. Nothing more than here. Clear na? Yes or no? Yeah. Then similarly one more example. See here. Yeah, y is equivalent to, if y is equivalent to a cos, this is multiplication of e to the power of x. E to the power of x into a cos x plus b sin x. Then differential equation is. They will ask you. See ma, actually, if I take this as a into e to the power of x cos x, I can do it as plus b into e to the power of x sin x, I have to do it as. So now if you observe here, this is your f of x and this is your what ma? G of x. So actually if I go with my Wronskian determinant, see, check it out, Wronskian determinant, if I go it as, because the given function f of x and g of x, I will suggest you that this f of x and g of x, whenever the functions f of x and g of x is small functions, then go for Wronskian determinant. Otherwise, directly substitute, do the direct thing, because here we are having the two constants a and b are the two constant. Two time differentiation you do it as, you can get directly answer. In this also you will have it as, but it makes you the thing as what the complexity. So y e power x, that is f of x is what e power x cos x. Then again this is nothing but what e power x sin x. So why I am telling this is, see here I have to do it as y dash y double dash x. So for this derivations, UV rule people have to do it as. Anyhow, if you do this, you will have the same answer, but somewhat it will be a complexity thing. So that is the reason why we will go direct approach. You will go with the direct approach. So that is a is equivalent, y is equivalent to a e to the power of r. You can take it as what directly. You can make it as what they had given in the problem. What they had given in the problem here. So y is equivalent to e to the power of x into a cos x plus b sin x. See, Wronskian determinant also you can do it as, but it makes you think as what somewhat complication. So that is the reason why, to eliminate that, I'm just giving this analysis. That's nothing more than that. So y is equivalent to this one. Yeah, so do the differentiation here for this. If I do the differentiation, I'll have here what y dash is equivalent to UV rule. So for e power x, what e power x is the differentiation. So e power x into a cos x plus b sin x will be there. Next, plus e power x is a constant. Then for this, you'll have it as what cos x minus a sin x will be there. Cos x minus a sin x will be there, plus b cos x will be there. Am I correct or wrong? Yes or no? Yeah. So if you observe here properly, this total e power x into e power x into a cos x plus b sin x, this I can mention it as what y na? Yes or no? This I can mention it as what y I can mention it as. Am I correct or wrong? Yeah. So now what I will do is, if I mention this, what I will get as here, y dash is equivalent to y plus e to the power of x into minus a sin x plus b into cos x will be there. From this we can represent as what y dash minus y will be what because that I can use in the another statement, because I already solved. So that is the reason why I am representing. Or otherwise you keep with you, then you can go with the direct thing. It doesn't matter here. Right. For this I have to go with the second term derivation. Am I right or not? So here I require one more term differentiation. So let me take the differentiation. Whenever it is required, we will derive it as, not a big deal. So y dash differentiation will go with as. For this you will have it as y dash plus again UV rule. So e power x differentiation, e power x will be there, minus a sin x plus b cos x will be there. Then for e power x into minus a cos x will be there. Then minus b sin x will be there. This is what the criteria. Am I correct or not? Yes or no? So again, if I do something, if I do something, y dash plus e power x into minus a sin x plus b cos x. Then if I take e power minus as a common here, I'll have it as what? E power minus e power x as a common, a cos x plus b sin x will be there. Yeah, if you observe again, actually this is your y dash, y double dash, this is. Yeah, if you observe properly here, this keep minus aside, this e power x into ax cos x will be what again, which will be what, y or not? Yeah. Then if you observe properly, what is this? E power x into minus a sin x plus b cos x will be what? I can represent this as what y dash minus y only na. Here I am representing that y dash minus y is equivalent to e power x into minus a sin x plus b cos x. I can represent it as this. I am just using that result. This result I am just using here. Okay, don't get bothered. So here I am representing that result. So that means that e power x into a minus a sin x plus b cos x, I can mention it as y dash minus y. I can mention it. So now if I replace all those, what I will get as here? If I replace this, I will have here what y double dash is equivalent to y dash plus y dash minus y will be there. So now if I simplify it as y dash is equivalent to y dash plus y dash 2y dash minus 2y will be there. So if I take all as a 1 plus, so I'll have here what, which is y double dash minus 2y dash plus 2y is equal to 0. So this is the differential equation for the corresponding equation in such a way that you can able to solve it. As this problem you can go with your Wronskian determinant also, but this Wronskian determinant again these differentiations, see this differentiation makes you what, the thing has what, somewhat complex. So in order to eliminate that complex, I'm just going with what, my direct approach. So that in such a way that see you people will have a doubt, sir, at the time what I have to do it as. So by practice you will come it as. Clear out my point? By practice you will come it as like this. Clear, mama? So this is the way of representing the form, that is the formation of a differential equation from the given equations. Clear out my point? Clear up my point? Yeah. So this is about for this session. So in the next session we will start with the solutions of the differential equation. Solutions of the differential equation. Again, the solutions of the differential equation you people will have much more. That is first order and first degree. Then we will go with what, differences. That is higher order linear constant coefficients. Things will be there. So that we will discuss in the next session. Clear up my point? So this is about the particular introduction part of your differential equation. So in the next session we will start with what, the solutions for a differential equation. Clear up my point? Yeah, fine. Thank you.